Hello.
I'm using it.
Hello, madam.
Yes, sir.
See, I'll just start. I mean, PowerPoint is not getting it. Afterwards, I'll do it. No problem.
Okay, sir.
I'll start the lecture. Because I think, I mean, that PowerPoint, I mean, I wanted to do it slightly some part of the board and some part of PowerPoint.
Okay.
It will, I mean, we'll start. That's not a problem.
Yes, sir.
Let them join first.
Okay.
All of you can see the board also, na?
Yes, sir.
Okay.
Yeah. इको नाही मोबाईल बंद असतो
तुम्ही केलं
तो इको येत राहील नाही चालू इको हेलो
मैडम आपका थोड़ा वॉल्यूम कम रखो तो फिर क्यों दूसरा मुझे किस गलती से फोन
ऑफ किया।
मेरा भी बनाना है लेकिन आपको कर दो। हेलो हेलो मैं क्या बोल रहा था ये आप करें ना पानी पे नहाना है क्या? ये देखो मैं सर ये मैंने निकाला है और इसलिए आपको दिख रहा है। हेलो हेलो नहीं सर ये कौन सा है सर आपका?
एक एक ऑफ करो।
हाँ इसे बोल रहा हूँ
एक ऑफ करो।
आता मी कुठं तरी दुसरं लॉगिन केलं त्यामुळे मला हेलो सर yes sir
हेलो
हेलो हेलो
Hello.
मैंने क्या ठीक
Hello. Good morning, everyone.
तुमचा आवाज नाही
गुड मॉर्निंग मैम गुड मॉर्निंग मैम
Sound बंद है ना सर, एक सेकंड. Hello.
हेलो
Good morning, everyone. Are we
गुड
audible?
मॉर्निंग मैम यस यस मैम
Anybody's mic is on? Please keep your mics off and your cameras off, please.
हेलो
We'll be starting in just 2 minutes. Welcome to this 4th day session.
हेलो
I hand over the mic to Dr. D.M. Bosley, sir, today's session in charge. Over to you, sir. Bosley, sir.
Jai Dr. Sonia madam, thanks for giving an opportunity. Jai all the respected participants and today's Honorable Speaker. Myself,
Bhosle, you are not audible.
I'm not audible.
Yeah, you have to speak a little bit loudly.
Okay.
Sir, he is audible to me.
Oh, he is audible to you, but not me. Okay, fine.
Yeah, no problem.
Okay.
Hopefully others may listen me.
Yeah, no problem.
Okay. So once again, I welcome one and all in the today's 4-day session in the faculty development program on capacity building in research techniques. My dear friends, today we have the 2 sessions. The first session is going to carry on by the respected Dr. Arvind Kulkarni sir, and the afternoon session is going to conduct by Dr. Babu Jakaria sir. So indeed it's my pleasure to introduce of the today's first speaker, the Honorable Dr. Arvind Kulkarni sir. I will just go through his, I will just make you the little exposure about his total achievements of the life. In fact, his biodata is very wide, so I will only just read out the very important his achievements. Dear friends, Dr. Arvind Kulkarni sir is a professor and head of Department of Computer Studies of Cyber College, Kolhapur. He is working more than 33 years of his life in the teaching fraternity. On his credit, so many things are there, especially in the 33 years of his teaching life. He worked as an in-charge director for 2 years and director for 2 years in Chhatrapati Shahu Institute of Business Education and Research, Cyber Kolhapur. He is a recognized PhD guide by Shivaji University in Commerce, Computer Management, Computer Applications, Applied Statistics. He is also recognized as PhD guide by Graphic Era Deemed University, Dehradun in Computer Science and Engineering. He is also recognized as PhD guide by Symbiosis International University in Computer Studies. Sir is also recognized as permanent postgraduate teacher for MPhil, MCA and MB courses. He has worked as a reviewer for different research papers published by national and international journals. Sir has worked as a research person at various events held at national and international levels. So far, he has successfully guided more than 12 students of PhD degrees in the different areas. I will not go through all the details of it, but you will find that these topics are very interesting and very, what I should say, is very opt kind of thing. He is working as a consultant for the technical advisor and computer consultant for different cooperative, sugar, milk industries, and number of cooperative banks in Kolhapur and surrounding areas. He has worked on various UGC projects on the major and minor, and very notably, more than 100 papers he has published with a very good citation at national and international level. I think if I'll go through all his biodata itself, it will take 1.5 hours. So I will just come down to his last part. He got very notable membership of various institutions. He is a life member of International Federation of Operation Research Society. He is also life member of Indian Society for Probability and Statistics. He is a life member of Indian Association for Management Development. He is a member of Computer Society. He is the chairman of Board of Studies in Production, Quantitative Techniques and Statistics in the Cyber College. He is a member of Research and Recognition Committee of Solapur University in the subject of Computer Science. He is a member of Board of Studies in Statistics, Karnataka University, Dharwad, and is the alumni of IIM Ahmedabad. So likewise, he's got very wide kind of the biodata. I hope you all will enjoy his knowledgeable session of his first session of today's. So without wasting much of the valuable time of all the participants, I just request and I once again welcome from bottom of the heart today's guest speaker, Honorable Dr. Arvind Kulkarni, sir. Sir, over to you, Dr. Arvind.
Yeah, sure. Good morning. I hope I'm audible and you can all people see the board, participants.
Yes, sir, yes.
Good morning, sir. You are audible.
Okay, good. Well, I mean, first of all, let me welcome you all for this particular FDP on research techniques. Well, today I'll be discussing on the concepts of statistics. Let me start. See, I'll be referring more on the board as such. Well, when you start with, the topic as statistics as such, how this particular word has come into the research as such. When we say that what is statistics, all of you may be knowing it, but basically let me start with meaning of statistics as such. It is said that it is nothing but collection and interpretation of data. Statistics means collection and interpretation of data. Now, that data, whatever you collect, maybe you can use different methods to collect the data. As earlier discussed by some of my colleagues on terms of sampling or etc. We collect first the data as such. You can use different methods for collecting the data. And then again, remember one aspect. When I say concept, you should also remember one aspect, that data itself is a plural word. Never we should speak datas. What is the singular of that? We should always know that datum is a singular of data. So therefore, as I said, I'll be going in for more in terms of conceptualization of statistics. See, first of all, we try to go for collection of the data. Now, you collect the data by different methods. I just give you a small aspect and then go back to my own statistical aspects as such. See, when you collect the data, use different sampling methods. There, the important aspect you would remember is always we take care of probability sampling as well as non-probability sampling. Remember why I am specifying it, because the reason behind it is that statistics is completely concerned with probabilitical aspects as such. Now, when I say probability, that is when you try to collect a data, you have to be very, very particular about when you use any sampling method as such. One is you are giving equal chance to selection of each unit of the population. That becomes a probability sampling. Therefore, when I say that when you try to go for collecting the data, you use probability sampling means what? You are trying to give equal chance to each unit of the population. That is probability. Means what? Here you should know the population and then you are giving equal chance. Means what? Something like lottery system. So therefore, probability sampling takes care of that. And then when I say that, and again, when you give equal chance to each unit of the population and draw randomly certain units, that becomes a simple random sampling. We should not use random sampling means just randomly I select. But remember, random sampling means I am trying to give equal chance to each unit of the population. That is why we say, and then draw it randomly. What happens in stratification? You try to make groups. What is that group? Literate, illiterate, male, female, educated, uneducated, different income-wise, category-wise. And each category you represent as a group, and from each category you draw randomly. Again, giving equal chance to each unit of the population. That becomes stratified random sampling. And in what happens in systematic sampling? You select a first unit randomly, and then remaining unit you try to pace it in terms of equal intervals. Means what? Suppose you are trying to go for some collection of the data from residential area. So what you do? Randomly you pick one residence, one house, and that number may be 10 or 15 something, and from that house onward, remaining residences you try to give equal interval. That is, if you select a fifth, then go for 15, 25, 35, etc., giving equal interval. So therefore, this is what? Systematic random sampling, wherein you try to give first unit only as a randomness. So therefore, this is a brief idea. Non-probability sampling means, as usual, convenient, cluster and all. There is like, I take this was convenient, I have taken a sample. So here itself, when you talk about probability, these things should be taken into consideration. Why we require this? Because whenever you go for first data, there is something called as primary data and secondary data. For primary data, you require these aspects. That is, whenever you make a survey, try to see whether you know the population. Population is finite, maybe sugar factory, something like you know the members, you want to take some data from that. When population is known to you, you can go for probability or something in terms of that. So this is a brief idea about a sampling as such, wherein we go for collection of the data asset. And then we come across the first aspect when we talk about statistics. As I say, we always talk about, before going in for different aspects asset, we always talk about something called as variable. What is variable? We always say that a thing which varies is a variable. Now, can we say that a thing which varies is always referred as a variable? No, because in that way, beauty is also varies, honesty also varies, intelligence also varies, but they cannot be treated as variable. They are all attributes. What we mean to say that they are all qualitative aspects. Then what is a variable? Now here comes one important word, what we call it as a quantitative. Okay. Now what do you mean by that? A quantitative thing which varies is referred as a variable. Now quantitative means when you assign a value to a aspect. Value means what? Whenever you say let x be a variable, means what? You are attaching some value to x. So therefore, variable means you have to always remember that a value. We have to give some value to it. Then only it becomes a variable. Because in statistics, it plays a very important role. That is a variable. Because whenever we try to go for collecting the data, we should always remember that we are talking about a variable wherein are we going to consider the values or not. So therefore, a value which varies is therefore we say a quantitative thing which varies. Because of that only all these quantitative techniques and remaining aspects have come into picture. So therefore, now this is what we call it as variable. Then what are the types of variable we come across? There we come across two types of variables. They are nothing but always, some people say dependent or independent. There are one category of that. But what are the types of variables? See, it would have been better that if we go for some interactive. Anyway, it's not a problem. So what are the types of variable? We always say in statistics, these are nothing but there is a discrete and continuous. Okay. These are referred as types of variables. Now then, what is discrete? Some we say which is not continuous. No. Discrete means a variable whichever is possible for you to count. Means what? Number of students in a class, number of children per family, number of jobs processed by a computer, number of computers, number of people, whichever is possible for you to count. Then what is continuous? Which is not possible to count, but whichever is possible for you to measure. That means what? height, weight, amount of rainfall, all this come under category of continuous variable. Discrete variable, whichever is possible for you to count, again, you are representing the values here. Remember, variable when I say value, discrete also variable values, continuous also value. Now then the question comes, the important aspect, number of stars on the sky. Is it discrete or continuous? Many of the people say because it is not countable, we can say no. But remember, I am not asking how many stars are there. But it is possible to count. But we use the word countably infinite. Right? This is what important word you have to remember. A variable which takes into account countably infinite sets of values is referred as discrete variable. And therefore, countably infinite, uncountably infinite. Then what is discrete? Uncountably infinite. Because number of stars on the sky, they are countably infinite. Uncountably infinite, whichever is measurable. So we give range and all those things. So therefore, remember, there are two types of variables, discrete and continuous. Discrete means countably infinite, that is number of stars on the sky. So therefore, this is a brief conceptualization in terms of what is discrete and what is continuous. Then we come across what we call it as, see, basically when we start with statistics as such, you know that we do come across something, the word called as classification. This is a basic fundamental. Classification and tabulation. We always classify the data. Means what? You take different, whenever you have got a raw data, you classify the data in terms of columns, rows, etc. And then you represent it by a table. Now, in that classification, in that process of classification, you know, why we do it, condense the data and all those things. That are all different aspects. And what are the types of classification? See, when we start with that, what are the types? How do you go for classifying the data? And what are the types means what? Whenever you classify the data, are there any type? See, first thing is always we say geographical classification. That is, whenever you concentrate the data, whenever you represent the data in area wise. Means what? Area. Suppose I say that the population in this particular area is so much. The educated population in this area is so much. When you represent the population area wise, that becomes a geographical classification. And then we have something called as, suppose you represent a classification or data in terms of year wise, that the population in this year was so much, the educated population in this particular area, particular year was so and so. When you represent the data in terms of time wise, that becomes chronological classification. Right? Chronological classification means whenever you represent the data in terms of time wise, year wise, month wise, etc. Then comes what I said just now, classification, quantitative classification. That is, just know what I said, quantitative aspect. Wherever you have got something measurable aspect, that is, you want to study the amount of rainfall in this particular area, number of people, those who have got height more than 5 to 6, 5'8", number of people, those who have got weight more than 120, 100K, something of that. Whenever you represent the data in terms of quantitative wise, measurable wise, that becomes what we call it as quantitative classification. Then comes the other aspect, that is whenever you represent the data in terms of qualitative, that is the classification is with respect to quality, good quality, bad quality. That is whenever you have got attributes as such, data is represented in terms of quality aspects. That is qualitative classification. So now This is what we call it as the different types of classification we come across in our day-to-day life as such. Okay. And quality, and see, remember, once we take care of that, that is types of classification, because whenever you collect the data, first after collecting the data, it is most important for us to classify the data. And once we classify the data in terms of quality wise, area wise, chronological wise, then comes what method do you adopt for classifying the data? That is what we call it as methods.
What?
Right? Methods of classification. See, the process of classification using
नाही मला नाही सांगितलंस तू
method.
70 की 80 80 सगळ्यात पहिले तुझी मार्क कळली
That is, we say that
किती 68
we take a particular class interval or something and we represent the data. For example, let us take it.
science
We have got daily wages, number of employees.
Hello. Please mute your mics, please. Shamla.
Okay. Now, this is one method of classification. That is, whenever you are given a data, we classify the data according to this particular aspect. What do you call it as? This method of classification. Remember here, whenever you get a person having exactly wages rupees 10, you take it in the next class. That is second class. Therefore, what do you call it as? The value of the upper limit is excluded from the class. This method is called as exclusive method of classification. Right? This is referred as exclusive method of classification because the value of the upper limit is excluded from the class. That is why we call it exclusive. And remember here, this is usually adopted in different surveys. Better not to have an ambiguity in any of the classes, we use this. And another one will be, if you represent in terms of, that's what we call it, 0 to 9, 10 to 19, 20 to 29, 30 to 39. Here what? Number of employees. See, when we say that, here what? The value of the upper limit is included in that class. So this is referred as inclusive. See this, when we use, whenever you want to represent a discrete data, discrete means what? You have a whole number, something in computers we call it as integer also. That is number of jobs, number of machines, number of, whenever you present in terms of that, that is what we call it as inclusive method of classification. Here, the value of the upper limit is included in that class. This is what we call it as method of classification. Once we know these type of things, there you have got class interval, class frequency, all these things are generally given. The frequency of this is class frequency. Generally, we represent it in terms of that. So therefore, once, see here I have already given inclusive method and as well as exclusive method of classification. See, once we already, I think some person might have talked to you the measurement levels also. I am not going to go much about that, but you should remember that See, basically, once we classify the data in terms of inclusive method or exclusive method of classification, then we go for different measurement levels. But I think the measurement levels have been already discussed by some of the people. But anyhow, whenever we go for, representing in terms of ratios, we go for ordinal. Sometimes we say that ordinal and internal and interval scale, all these things come under statistical aspects. And then once you go for measurement levels, then comes important topic in first topic, that is what we call it as measures of central tendency. See, basically, when we start with statistics as such, measures of central tendency, here, why I have given summation notation is because in measures of central tendency, the first thing comes into picture is averages. You know that, I did not have to explain how do you calculate average. Average, you know that number of sigma. Why I have given this, the major notation we always use sigma, that is sum of all the variables. Sum of k, sum of the p, sum of. So therefore, what is averages? Averages means what? You know that sum of all the observations. And measures of central tendency. Why we call it as measures of central tendency? The reason is all the values when you compute average, they are in centrally located values. Therefore, whenever you compute averages as such, it is lies in the centrally located value. Now, of course, calculation, etc., I will not go for it. But basically, what are the important advantages and disadvantages of averages? Let me think of it. Remember, averages sometimes, always we say averages is a good measure of central tendency, wherein for everywhere we require, maybe like average rainfall, average amount of expenditure, average salary, everything will be considered on the basis of average. But what is the basic defect of averages? See, remember that in measures of central tendency, we have got average, mean, mode, median, all those aspects. Now, what is the basic defect of averages? If you say that, suppose if I take an example that a student, maybe there are two students who have scored different percentage of marks. That is what we call it as 50, 60 and 70 in the first year and second year. Some students have scored 70, 60 and 50 percentage. Now, when you talk about average as such, 60 and 60. Suppose if you are not given details of the data, then what is the conclusion of only on the basis of average? Both the students have scored average 60%. Whereas if you actually look towards the details of the data, one student has consistently improved and one student has consistently deteriorated. So therefore, average may lead to wrong conclusions if the details of the data are not given to you properly, because only on the basis of average we try to conclude all the aspects. So therefore, this has to be remembered clearly. Average may lead to wrong conclusions. And then another one, another important defect of average. Remember, average cannot be calculated for open-end classes. I'm just giving you the defects or demerits of average. What do you mean by open-end classes? Sometimes you take, say, class interval 0 to 10, 10 to 20, 20 to 30, and you say above 40. Now, above 40 means what? It is an open end. And above 40 means maybe 60, maybe 100, anything in terms of that. So therefore, average cannot be computed for open-end classes. And that is why we say, even whenever you refer any of the journal or anything, if somebody has taken some mean, but if this type of data, that is wrong, because there is no upper limit for this. And then what upper, then you may say, I've assumed some upper limit, but when you give a class, it is an open-end class. Therefore, open-end classes, you cannot compute. And that is why, remember, we go for next measure, what we call it as median. Remember, we don't try to go and study for median just because it is in the syllabus. You should remember, whenever you have got a data wherein it is only important in terms of the middle term and end values, because always median is what is considered in terms of all open-end classes. We are not bothered about the open-end classes or anything. We just concentrate upon the middle class whenever we compute median. Therefore, whenever you have got this type of data, open-end classes, median is the most suitable measure of central tendency. Another important aspect of, if the defect of mean, what we call it as average, just I'll say, and then we go for next. That is, suppose if you take it as some value, like x is 7382, and if you calculate mean of this will be nothing but 5. Suppose you subtract x minus x bar, that is mean, you know that x bar here is what? 20 by 5, that is 20 by 4, it is 5. Now, if you subtract mean from this particular data, it is 7 minus 5, 2, minus 2, 3, minus 3. And when you sum this, that is sigma of x minus x bar, it is 0. And remember, this is always true. Any data you take, if you are trying to find out the deviation of mean, it is always 0. And this is the defect of average. And because of this, we proceed further like variance, standard deviation, etc. Remember that. You should always know the background, that why one has to go from mean to variance, averages to that. Because you know that this particular defect has to be eliminated. Because we always want, if you are given only average, I want to know to what extent average is deviating from the actual values. If you know only average, that is average height, average income, average expenditure, I should know what extent average is deviating. That is why we go for standard deviation, variance, and everything in terms of that. And this was the main aspect of that. When I go for discussion, I will discuss about that. But remember that these are basically defect of mean. And then already I have given you median means what? Exactly the value at the middle term in terms of that. That is what we call it as median. And again, for median, you take for any example, like 3, 4, 5, 6. Maybe this may be a median, what you call, whatever may be there in terms of that, or whatever. You can take 3, 4, 5, 6, 7. Now, when you talk about this, maybe odd, maybe even, according to that, changes. Now here, suppose if I ask you to go for calculate median, so you always say that middle term is the median. Now remember here, even if you change this, median is not affected. Means what? Median is not affected by extreme observations. Again, this is the defect of median. Whereas in average, what? It depends upon all the observations. And here, if you median value only, even if you take anything here, that's not a problem. So therefore, again, we say that it is not at all dependent upon extreme observations. And then the last one is mode. That is again we have got something called as quartiles, quintiles, deciles, percentiles, all those in. It is a one term of median asset. We have got median itself is sometimes we call it a second quartile. Then now, when we say that mode, what is mode? See, we always remember one thing. Now we have said mean depends upon all observations. Median depends upon only central liquidity value. What is mode? Most frequent occurring value. Now, what do you mean by most frequent occurring value? Maximum. Suppose, for example, if you go, and what I say, very important aspect has to be considered here. most important in the sense that most frequent occurring value. For example, if you go to any shoe shop or like Bata or Corona or something, always if you ask them, most frequent odd number is number 7. Means what? It is, we can call it as most frequent occurring value. Whenever if that particular number may fit to many of the people assets. So therefore, mode is most frequent occurring value. Maximum frequency, that is maximum people will go for that. So therefore, again now, you have seen that how one by one, we go on making changes. What happened in mean, what happened in median, what happened in mode, everything in terms of that. So therefore, this is all about measures of central tendency, right? Now, here, what we have considered here is always a concentration was given to centrally located values, centrally located aspects, everything in terms of that. Now, we have taken into account mean, median, mode, something about those aspects also. So therefore, here I have given something, you can go through it, some examples also I have given on median, mode, and then some of the aspects, okay? And then, next one is, once we have considered in terms of measures of central tendency, we go for measures of dispersion. Now, why measures of dispersion is required? Dispersion means what? Scatteredness. That is, as I said earlier, the most important defect of arithmetic mean is what I say, algebraic sum of the deviations from arithmetic mean is always 0. That is, when I say, now, if you want to know to what extent mean is scattered, average is scattered from the given observations, you cannot compute. You will never come to know by this. That is a most important effect of arithmetic mean. That is, when you calculate sum of the deviations, always sigma of x minus x bar is 0. That is, if you want to go for what extent average is scattered, deviating from the actual values, you will not come to know. So therefore, we go for measures of dispersion. What is the important aspect in measures of dispersion is, here we are trying to compute to what extent the mean is actually deviating from the actual values. Scatteredness, that mean is scattered. So therefore, what people say that the first important aspect what they did is they brought modulus sign. What is the modulus sign? Negative will be converted to positive, and they call it as mean deviation. Mean deviation about mean. That means what? Why we have done it? Because we know that we cannot compute the deviation. So therefore, they brought modulus sign, and all negative will be converted to positive. And then once we add it, we compute mean deviation about mean. Similarly, mean deviation about median, mean deviation about mode, everything can be computed. And what is the important aspect is, we brought modulus sign to know what actually deviation is there. And then we made it a sum, and then we call it as mean deviation. Now again, what we say here is, this is one aspect of getting a deviation of mean. Why it is required? Because we always want to know, if you are only given averages, I want to know whether average what we have computed has how much of deviation. That is, on average, what is the deviation? So therefore, this is one aspect. And again, it was thought that modulus is an eye washing technique. When you bring a modulus sign, negative is converted to positive in an eye washing sign. So the best what the people suggested is square it, because squared quantity is always positive. Square it. So we square it, then it will be nothing but, okay, and okay, we square it and then we sum it and divide by number of observations. That becomes variance. That means what? Why we have done all these things? Just to know to what extent variance is there, what extent average is deviating from the actual values. So therefore, we compute variance. And then we have got a square root of that variance will be standard deviation, something in terms of that. So therefore, why variance is required? Because variance is nothing but sum of all the observations in terms of squared. Because always we say squared quantity is positive. Squared quantity is positive, and therefore variance in that way will come the same way. Root of that is standard deviation. So we always know that sigma is root of that. So whatever summation of, we say that if you have got only a data of that, summation of x minus x bar bracket raised to square, it is just will be sigma square will be variance. Now, why, what is the purpose of this is always we say, in statistics, we always say mean and variance are bread and butter of statistics. Whenever you go for any data, we first compute mean and then go for variance. We always say, therefore, when you talk about statistics as said, they always ask what is the mean and what is the variance. So we say any data you go, any probabilistic aspect you go, we need what is called as mean and variance. So therefore, we always say mean and variance are bread and butter of statistics as such. So therefore, you should know the background already. I mean, you know, if you give a data, you get mean and variance, but you should always know the interpretation of that. So therefore, we do go for mean and variance computation as such. This is what statistically talking in terms of that, we say that calculate mean and calculate variance. Then another important measure in only when you have got a single variable like wages, weight, rainfall, everything. Another one will be, we call it as very important, that is CB. We call it as coefficient of variance or coefficient of variation, whatever. CB. It is always given by sigma standard deviation x bar into 100. Now, see, this CB, what you call it as coefficient of variation, plays an important role in almost all surveys, in almost all studies. Now, CB, whenever you calculate CB, you know, remember the formula, standard deviation, and then the standard deviation is what? Total variation divided by mean. Means what? Total variation divided by mean will give actual variation. When you multiply by 100, it is percentage variation. That means what? CB is a measure of very, very important aspect. Now, suppose when CB plays an important role, whenever you want to have comparison, comparative analysis. That means what? You want to compare wages paid in one of the companies and wages paid in other companies, or wages before labor settlement, wages after settlement, wages before going on strike, wages after strike. When you want to whenever you want to go for it, comparative analysis, CV plays an important role. Means what? It goes for variation. That is, suppose if you want to go for consistency, test of consistency, that is what? If you want to test the consistency in terms of that, for example, you take an example of who is a consistent player. Whenever you talk about cricket match or something, who is a consistent player? whenever CV is, because some people, some of the batsmen, what they score highest in 1 or 2 matches, then they'll be slowing down. But some of the people are therefore lesser the CV, better the consistency. Similarly, if CV is less, wages have become less variable after the settlement. Suppose CV before labor settlement was 30% and CV after settlement was 20%. Means what? CV has decreased. Means what? The wages have become less variable after the settlement. So therefore, CV gives you a test in terms of consistency, variability, etc. So therefore, whenever you want to do a comparative analysis of certain aspect, you can use coefficient of variation. And that is very, very important. Nowadays, CV is playing an important role in almost all. That is aspects of that. You can take about surveys, social research, you can go for any industrial, anything. So therefore, coefficient of variation is an important measure of dispersion here. It always gives you percentage of variation because as the formula states. Now, once we have gone through all these type of things, here, whatever measures of uncertainty, dispersion, everything was concentrated upon a single value asset. That means what? You have to remember that we are trying to go for one single variable asset. Sometimes what happens, you may be required to go for study of 2 aspects at a time. That means what? Income and expenditure, demand and supply, height and weight. Whenever you want to, now we are talking about 2 variables. We are talking about 2 aspects. Whenever we want to relate 2 aspects as such, that is, I want to know as the income goes on increasing, whether the expenditure has increased or decreased. As demand. So therefore, whenever you want to go for relationship of 2 aspects, there comes one that is called as correlation. That means what? What is the correlation? Correlation means correlation. That is relationship between 2 variables, right? Correlation means we have to think in terms of relationship between 2 variables. That is, whenever you want to relate income, expenditure. So therefore, now say for example, you have got, what we say that whenever not only 2, you can go for 3 variables, 4 variables. That is, if you want, a particular, you want to have a product, maybe depend on so many factors. Sometimes you want tissue, it depends upon soil fertility, amount of rainfall, what is in terms of, so that sometimes one important aspect depends upon so many variables. That time we are trying to go for correlation. We are trying to find out the relationship between variables. So in that correlation, we have different types of correlations. As I said, so first thing is we are trying to relate. First will be positive correlation. Now, what is this positive correlation? That is the relationship between 2 variables goes in the same direction. Means what? As income goes on increasing, expenditure also increases. That is, both are related positively. That is what we call it as positive correlation. Means what? We are trying to represent. Therefore, I always say, whenever you want to go for testing the correlation, first see whether there is a relationship or not. Is there any relationship between soil fertility and amount of rainfall? Is there a relation between amount of rainfall and what you get? Means what? Therefore, when you are saying that both are dependent, if it is independency, no. If both are dependent, then whether whenever it increases, both go in the same direction. That is called as positive correlation, right? And then one is, we have negative, that is both go in a opposite direction. That is, as demand and supply. Sometimes if demand goes on increasing, supply also increases. If demand goes on, that is, you have to see how these are related. If both are going in a directly negative relationship, if one goes on increasing, other goes on decreasing. You can go for a lot of examples on that. So therefore, maybe demand, and supply. If the supply goes on increasing, demand may be decreased. If the demand goes on, it all, you have to see, both are related in a, therefore, they deviate in an opposite direction. That is what we call it as negative correlation. And then another important aspect comes to, if there is no relationship, we call it as no correlation among both the variables. One aspect, that is, we always say linear correlation. That is what we call it as linearity. Now, we always say that X and Y are related linearly. What is the meaning of linearity? That is, if one changes, other also changes with a constant proportion. See, we say, first we have to find out the relationship. Yes, there exists relationship. Now, what is the relationship? Sometimes we say that demand and supply are related linearly. What do you mean by that? For a change in some, there is a proportionate or a constant change, then we call it. Therefore, you should remember always when to use the word linear, when to use the word non-linear. So therefore, just to give you an example, if you say X goes on changing, that is, we say, that is X and Y. So therefore, you have to be very, very particular about whether how they are related. See, for a unit change in the value of X, Y changes by constant to 2 units. Now you can say whether is it that Y and X are related linearly? Yes. You can express Y as 2X plus 3. Means what? It is expressed. Therefore, we say that X and Y relative. We can call it as Y equal to AX plus B. Means what? You have to be very, very particular about whenever the word, see, that is for a change in X, Y, so corresponding Y changes by constant to 2 units. And whenever it is expressed Y homogeneous of degree 1. So therefore, you have to be very, very particular about correlation. This is called as linear correlation. And if it is not, it is called as non-linear correlation. Now again, correlation is relationship between 2 variables. When you try to understand the relationship between 2 variables, it is correlation is very important. There you come across positive, negative, linear, non-linear. So therefore, we have to be very, very particular about linearity, because in economical way we say that they are related linearly. When we say linear, you should always remember that change is there, but corresponding change, you can call it as proportionate change, constant proportionate change, etc. So therefore, this is what correlation in terms of linear. I am just giving you, always it should lie between -1 and +1. You have got negative correlation, positive correlation, etc. So now, whenever we try to express any of the variables as such, height, weight, or in terms of general aspect, we should be very, very particular about what type of relationship. So therefore, when you compute, we have got Carr, Pearson, so many coefficients, we always say R. Now, R is correlation coefficient. We say 0.9. Value of R is 0.9. Means what? Highest correlation is there. That is, we say there is a strong correlation between income and expenditure. When I say calculate coefficient of correlation for income and expenditure, if you got a data about that, and if you get the value as 0.99 something, we say that both are highly correlated. Therefore, always we say, if the figure is more than 0.5, we always say that it goes with a higher range. So therefore, whenever you compute correlation coefficient, the interpretation of that is very important. When you say that R is equal to, you get some value that has to be represented clearly. So therefore, this is what we call it as coefficient of correlation. Then of course, you have got multiple correlation coefficient, that is if one variable depends upon so many factors. Maybe we call it as multiple correlation. When you calculate, there are two other aspects, that is income may depend upon some other things also, expenditure on luxurious item, expenditure on required item, all. So all these things can be, so we can have multiple relationship also. But what is more important here is, whenever you want to test correlation as a type of using some test or something, you should always say that first you have to find out there exists a relationship, and that relationship should be considered a probability. So this is what we call it as correlation as such. And then in measures itself, the last comes into one aspect, that is what after we have something called as, here itself in correlation we have got something, we have rank correlation also, that is, it is one of the aspect. Whenever you give ranks, that is you give, is there any significance of that? Suppose there are two people are giving a rank for different candidates, different people, different competitors, and then if you want to find out whether rank given by one judge and rank given by another judge, is there any relationship or not? Sometimes what this rank also plays a major role. Rank correlation, whether is there any exist a correlation between ranks or not. In general, you go on considering in a different aspects as such. Therefore, but correlation, before going in for correlation, we should be very particular about quantitative relationship among that. Remember that, as I said, this is all, whatever we have said, it is in a quantitative way, because we must know the values. Here, whenever we say correlation, it's got some value as such. So therefore, we take into consideration all of it. Then the last aspect comes into picture in this particular measures itself is one is regression. Now, what is regression? What do you mean by regression? Regress. See, the mainly regression has come into picture in terms of prediction. That is, you want to predict a particular value when you know other value. In the sense that we call it as regression means estimating a value of one variable when the value of other variable is known. Now, what do you mean by that? That is, that's why regression is used as a prediction for the prediction purpose. That is, if you know the sales, you can predict the profit. That means what? You know sales for 10 years and you know profit for 10 years. And on the basis of that, you can predict what will be the profit in terms of. Therefore, regression means what? Going back. Regress, going back, means what? We go and refer the past data and predict for further. Therefore, if one value is known, suppose I know advertising expenditure, then I can predict what will be the sales. If I know sales, I can predict what will be the profit. Because you know that profit and sales are dependent. In that way, income and expenditure are dependent. If I know the income, I can predict the expenditure. If I know the expenditure, I can predict what should be my income to satisfy all my expenditures. So therefore, here it is used as a prediction purposes also. So therefore, here we are trying to go for predict selecting one value, again we say that how this regression has come into picture. Something like, we try to say something like hereditary characteristics. Means what? Move back. We try to move back and try to determine. Means what? There used to be said, short fathers will have short sons and daughters. I mean, the long fathers will have long sons and daughters. Means what? Again, we say, is it true? When they, on an average, it is true. Means what? On an average, if short fathers are there, they'll have short sons, in the sense that their height will be smaller. See, these again, what we call it as hereditary characteristics. We move back, we try to regress, move back and see the data, move back and see what. And again, we try to come back to one aspect that on an average, it is correct. So therefore, again, we are trying to use the word on an average. So we, on the basis of that is, we use it as a prediction also. On average, it is true. On average, those who have that, then the prediction will be considered in terms of that. So therefore, this is what we call it as regression. Regression is nowadays very important in terms of the prediction purpose. We can predict what will be the different, aspect, that is depending upon the amount of rainfall, whatever has happened, we can predict what will be the growth of different groceries, something like, depending upon which are dependent upon the amount of rainfall. So therefore, regression is one aspect wherein we are trying to go for prediction purposes as such. So therefore, this is what we call it as, see, we have considered in a general way measures of central tendency, measures of dispersion and correlation, and then regression. This is a brief idea about initial concepts of statistics. That is, in statistics, we come across these type of aspects in a general way. That is how we go for measures of central tendency, what are the aspect, correlation, when to use correlation, when to use, regression and all, I have just, but one should, you remember one aspect, that whenever we try to go for predicting also, independent and dependent variable. That is, whether height is dependent upon weight, weight is dependent upon height, income is dependent upon expenditure, expenditure is dependent upon income. So this has to be considered, and then it can be used as a estimation aspect as such. So therefore, we have to be very, very particular about when to use regression, when to use correlation, etc. See, this is a brief idea what I have given in terms of concepts in statistics. Again, we have something called as, we have in statistics itself, we have something called, as I already discussed, hypothesis, statistical tests. That is, whenever we try to go for making a survey, whenever we go for collection of a primary data, and then we try to test, some hypothesis. That is, we try to presume something. What I mean to say, for example, recently the people have come up with COVID vaccine. Now, to what extent that vaccine is effective? Similarly, we take, some drugs, what extent that drug is effective? If you want to test that, then we take a particular sample and try to say test on it. Therefore, what I mean to say here is, hypothesis is one of the aspects in statistics. There are, whenever you want to test hypothesis, first you have to set an hypothesis and use some statistical test for that. And therefore, see, we have to be very, very particular about whenever we take a survey. Therefore, don't try to set more number of hypotheses. You try to set only one hypothesis or two hypotheses, but you should be very, very particular about whatever the hypothesis you set should be tested properly. Therefore, you can go for, especially hypotheses are being tested on major number of social surveys. So again, here we come across a parametric and non-parametric. See, whenever we say that you talk about measurability aspect as such, then you go for actual parametric. That is, you say that what is measurable, and according to that values are there. But if you are talking about some observation in terms of opinion, that you want to know opinion of this particular product, opinion of this particular vehicle, opinion of about this particular car. Then what you are trying to go for only opinion aspect, and you try to go for opinion. And in that opinion, you may divide it into different scales. Strongly agree, disagree, all those aspects. Whenever you go for opinion, that is actually becomes a non-parametric. Means what? Here you are collecting the opinion and then you are trying to test. Again, you can use some different statistical test, maybe chi-square, so many aspects. Because first of all, we should know whether we are trying to, whatever the survey we have taken, the survey is resultant of values or resultant of opinion. Because opinion, it goes on number of people who give you opinion in terms of what I have observed about the product. So therefore, we should be very, very particular about when to use which type of statistical test. So therefore, we have to be particular about hypothesis, what we set, and on the basis of what hypothesis you have set, you have to go for statistical test. So this is what I wanted to go for it. If any questions are there, I would like to answer. And then if some points are there, I'll again discuss. Yes.
Your lecture was very interesting.
Okay.
And we use regression analysis in the research purpose in pharmaceuticals.
Okay,
so
good.
Can you comment something about factorial designs?
Yeah, see, basically, when you go for factorial design assets, see, because it is a little bit of advanced one, but
yeah.
First of all, when you say that factorial, we have to think in terms of whether are you going to consider the factors. Means what? Suppose if you want to buy a particular product, what are the factors dependent on that factor? Therefore, we say always do factor analysis. That is something called as principal component analysis.
Yeah, correct, sir.
Okay, that means what? Which is therefore what we do? 10 factors are dominating. What we do? We go on eliminating one factor, then we come back to one important dominating factor, which makes us to buy the product.
Yeah, you are narrowing down.
Yeah. So therefore, see, this plays an important role in whenever I say that factor analysis, again, when people give you opinion, which opinion is dominating? Okay.
Yes,
so
yes.
This aspect has to be considered. Yes, next.
Thank you.
Your presentation was very nice, sir.
It was just,
Very clear, and you made a concept very much elucidated. Statistics becomes more complicated if you don't understand the subject.
You should take it as, not as a complicated subject. You should take it as an easy subject. Then you will understand it. Always, since it's a mathematical group, so therefore we have got a lot of problems, something of that.
Right. You're right.
Thank you, sir. Yours was a very lively and interactive session. Very enjoyable, sir. Thank you.
Good.
Sir, thank you for this nice session, sir. You were saying correlation shows whether there is a relationship.
Yeah.
So if I want to know whether there is a cause, I should go for regression, isn't it?
No, that becomes causal analysis. In the sense that for what cause? See, causal is different because you are not representing as a numerical value. Are you getting my point? See, that is different and this is different because first we have to find out whether relationship is there or not. Mathematical relationship, we say. Is it clear, sir?
Yeah, correlation I understood, sir.
Yeah.
The next step in regression, what is that we are measuring?
Yeah. See, for regression, you are predicting. Are you getting my point?
Yes, sir. Yes.
Because causation is different. You see, you can use it, but causation is different and prediction is different.
Okay, sir, I got that thing.
Yeah, because we are trying to find out, when I say relationship, causal factor is different. Always I say, when you want to go for relationship, take the values, use it, but regression I use for prediction. When I know one value, I predict other one. Yes, yes, next. Ask sir, no problem. Let us have a discussion, no problem.
Excuse me, sir. Uh, hello? Hello?
Yes, yes, you are audible.
Sir, I think a statistical relationship does not implies the causation. To determine the causative, one must be referred to the theories. It is correct?
Correct, because that's what I said, na.
Uh,
When you give values, that values you already calculated it, right?
yeah.
So what is the cause for that? No.
Okay.
Then you go for non-parametric as such.
Okay. Okay.
Then you go for what are the factors. Then you go for actual descriptive study, and then you go for all. Therefore, when I say, when you take an opinion survey, it is opinion. It is not a value.
Okay.
You are, suppose in opinion itself, you are attaching some value. Means what? If people say strongly agree, I give 5 marks. Means 5 points. Then again, for opinion, you are getting some numerical value.
Okay.
Therefore, for computation of all these things, I need numerical values.
Okay, sir. Thank you.
Participants are requested, before asking question, please let us know you are talking from which place.
Yes, next. I don't know, I mean, I could clear your concepts or not, but it was a short time, but anyway, I could utilize it in a proper sense. I think I'm. Yeah, any questions again?
All the participants are requested. If you have any doubts,
okay,
you are free to ask the question.
Yeah, sure.
We have another 5 minutes in our hand. Then we're going to close down the session.
Sir, actually, we don't, sir, good morning, sir.
Yeah, good.
Yeah, it is clear presentation, sir, but we have some less knowledge in this topic.
Okay.
Sir, could you please explain some statistical examples on regression, sir? So how we have to conduct, you can, in like social sciences, sir, some statistical, and how we have to approve it, and what is the significant values. So like that, could you please explain in this regard, sir?
No, I mean, what do you want? In the sense that
how we have to conduct it.
As I said, suppose, for example, now we have, say, let us take an example of company. For a company, the profits for the last 10 years, and the sales for last 10 years. Now, where we regression come into picture, first of all, you should know that there is a relationship between profits and sales. Okay, that there is a relationship. Now, I can use for prediction in the sense that if I know what will be the sales, if I know the sales, I can predict the profit. Now, here regression is used for prediction. So therefore, here what we want is values we want, and regression can be used when you got values, that is different values for different aspects. Maybe sales, maybe income, maybe expenditure, everything is known to us. See, here nothing should be considered if it is unknown. Are you getting my point?
Yes, sir. Yes, sir.
Because here, whenever we say, I want to compute regression, see, for that we need at least, always what we say that Here is the past values, past information is required for me. I should know income, I should know expenditure, I should know, profit, I should know sales, I should know these things. And then on the basis of the available data, I can go for using a regression, I can predict. But remember, when I use regression, I should know that both are dependent factors. That is, income is dependent upon expenditure, amount of rainfall is dependent upon whatever we get, and again, height is dependent upon weight, all. So therefore, first, what you have to do in your survey is, what are the dependent factors? On that dependency factors, you have to go for prediction. So as I said, again, regression is a statistical technique which estimates the value of one when the value of the other variable is known. Now I'm stressing more on value. Remember, sir, I should know the values. Is it clear?
Sir, yes, sir.
Good. Okay, anything again? Anybody has question, please unmute yourself and talk to me. Anything is there? See, there are still so many advanced topics are there, but whenever you take a particular survey or anything, as a statistical test, you can, therefore we say that whether you use parametric or non-parametric is a huge, one of the branches in terms of that. But what is more important is, therefore I stressed on certain point in the beginning itself, whenever you collect the data, collecting the data, therefore we say that the sampling method, what you use is very important. That is, therefore I say, I stress more on probabilistic sampling, wherein, if you know the population as such, and then whenever you try to select a sample, either using a randomness or, using a stratification, whenever you select a sample, if you are giving equal chance to each unit of the population, like say lottery, all the units in the box are giving equal chance. Similarly, and then you choose randomly, because random sampling, whenever used in sampling method itself, you should be very particular about that. I am trying to give equal chance to each unit of the population. So therefore, before going in for all these calculations, your sampling method plays an important role. What type of sampling method you have selected? Therefore, I always stress more on sampling method, because your basic lies on that. And then on the basis of that, you can go for different statistical tests, different measurements, etc. And again, opinion and then computed values as such. When values you have got, you can use all these measures like mean, variance, correlation, everything. Otherwise, you should only go for opinion, giving different scalable values, different values as such. So I therefore always when in research, whenever you go for research as such, you should be very, very particular about the method what you are used for sampling as such. Because collection of primary data, because your entire research depends upon the primary data, because secondary data is already published. You use that published data, and published data used for different purposes as that. But when you actually go for primary data, you should be very particular about the method you use for sampling as such. Yes. Anything again?
Well, sir, we are very happy to listen you. It was quite flawless.
Okay, okay, fine, fine, fine.
Listen you.
It was basic, you know, I mean, I could go for that, that's all.
Yes, sir. So, dear participants.
Sir, sir, I have a basic question. Your presentation was very informative, and I am from Symbiosis,
Okay.
attending your presentation, and the basics which we have, I think, forgotten for a long time.
Good, good. At least
Those
you know that
basics
you
for
have
us.
forgotten. That is more than enough.
Yeah. Yes, sir. Almost 20 years for my masters.
Good, good.
I wanted to
Yes.
know that you have talked about dispersion.
Yeah.
Dispersion, like negative, you have told that it becomes positive when you
No,
take it in.
the dispersion word itself is that because you are squaring. Yeah.
So I just wanted to know that how it becomes positive means, you know, I understand. I did not get that mean deviation concept very well. That why you taking the, is it meaning to say that we are going to put our negative values into positive values?
See,
Or what
remember, it is like this. See, whenever we compute mean and we try to find out the deviation of mean from the value, from x values we try to find out the deviation, and always x minus x bar and summation of x minus x bar is always 0 because we cannot get deviation. Sometimes what happens, mean is that it is a central value. So if you actually subtract mean from actual values and then add it, you don't get the deviation. So therefore, what has been done, why we go for mean, because we cannot get actual deviation of mean from the value, we bring modulus sign, and negative will be converted to positive to know the deviation. And in standard deviation of variance, what happens? We square it so that we say that squared quantity is always positive, and actually we can find out the deviation. Otherwise, never go for deviation as such.
Okay.
You got my point? See, mean, you have calculated mean, because now average rainfall I know, but to what extent average rainfall is deviating from actual rainfall?
Yes, sir. Average performance of I know, but it is not the actual performance which my child has done.
Yeah.
So maybe to get, you have to
compute variation, standard deviation. Once
I
you
got
get a variation, you can come to know that this is the actual variation from mean.
Yes. Yes.
See, variation, if you don't calculate, you'll never come to know what is the actual variation of mean from the actual values. Therefore, we go for. That is why I said one point. Mean and variance are bread and butter of statistics. Always. We need mean, we need variance.
Okay. Yeah. Thank you, sir.
I know, my dear friends, as everybody feel that the session should not end, but the time is always constant. So we all are very grateful to Dr. Ravi Kulkarni, sir. So always the statistics plays an important role in the authenticity of any research. And sir, you made it very clear. The technicality, you made it very non-technical. Because the word statistics itself creates some fear in the minds of researchers.
Good, good.
But you have made it.
No, fear. See, you should not have a fear. Fear is forget everything and rise again, you know.
After the session, definitely the confidence of the participants might have increased. So from the organizing committee, once again, I just wish all the success to the Dr. Ravi Kulkarni, sir, because he is playing the different kinds of roles. At present, he is also initiating the principalship of field department. And as everybody might have understood that how flawlessly he has teach the difficult subject in the easy one. So from organizing committee of the FDP, I just propose a vote of thanks to Dr. Ravi Kulkarni, sir, for his nice presentation. So thank you very much.
Thank
sir.
you, all the best. Thank you, all the best. Sarve jana sukhino bhantu, sarveshantu niramaya. All the best.
Thank you very much, sir. So all the dear participants are requested. Again, the second session will commence from 12:15 onwards. So you can take a break and again rejoin at 12:15. Thanks once again to one and all. Have a great time.